Amidst the quiet beauty of these islands, beneath vegetation, deep in the bowels of the earth, lies a wealth that took centuries to build. Grain by grain, boulder by boulder, layer by layer, the wealth of the earth accumulated. Through the years, it waited patiently for the right time to be discovered. In many of these places, life followed a quiet simplicity. The men and women lived side by side with this wealth, unmindful of its existence. They followed their own rhythm of life as the earth built up its reserves. "30 years ago, a man saw the possibilities that lay hidden beneath the earth. With ingenuity born from experience, and with a pioneering vigor, he laid down the groundwork for what is today one of the largest industrial complexes in the country, the Marinduque Mining and Industrial Corporation." The man behind this pioneering story is Jesus Cabarrus, a seasoned and well-known entrepreneur. A pillar of the Philippine economy in his own right, he runs the second largest corporation in the country in terms of fixed assets. From his paneled office in the heart of the nation's business district in Makati, he directs the growth of this industrial complex, a complex comprising the first nickel refinery in Southeast Asia, the third largest copper mine in the Philippines, and the largest cement plant in the country. Cabarrus is well prepared for the enormous responsibilities that come with his office. Starting off as an accounting major graduate in 1930, he worked his way up into the business ladder, serving as internal auditor to a number of pre-war companies. In 1942, he became controller of Elizalde and Company, a highly diversified corporation. 3 years later, he assumed the position of executive vice president and, as such, managed the company's agricultural and manufacturing interests. Cabarrus went into actual mining operation in 1949, when he set up the Marinduque Iron Mines Agent Incorporated. With a paid-up capital of 50,000 pesos, the company mined the iron ore reserves in Taluntunan, Marinduque Island. In the post-war years, this mineral found ready market in Japan. When the ore reserves at Taluntunan was exhausted, the company shifted its operations to copper mining in 1954. This decision augured well for the company, for it signaled the beginning of Marinduque's major role in the Philippine economy as an important dollar earner. To reflect the change in their operations and the company's plans to diversify, Marinduque changed its name in 1963 to Marinduque Mining and Industrial Corporation. In 1967, the company began its cement operation, and in 1968, Marinduque launched its biggest investment yet, the Surigao Nickel Refinery. With these 4 operations, Cabarrus has transformed the original iron mines into a diversified and multi-billion peso enterprise. To help him run the corporation, Cabarrus has selected as members of the board of directors some of the best businessmen in the Philippine economy. Together, they decide on the major issues concerning the company's operations. But while the head office is the seat of policy decisions, The nerve centers of Marinduque mining are its mine sites. High up in the mountains in eastern Samar in the Visayas, surrounded by lush vegetation, lies the first of Marinduque's copper mines operation, the Bagacay Copper Mines. It was first discovered in 1954. The mining property consists of 28 leased claims covering approximately 252 hectares. For greater efficiency, Bagacay Mine utilizes both open pit and underground mining. The Bagacay Mine is one of the most extraordinary mines in the world in terms of mineral composition and type of body ore. Since 1956, when commercial production began, Bagacay's more than 600 workers have mined a total of 4,663,000 dry metric tons of copper ore of both shipping and milling grades. The milling plant has produced 671,700 dry metric tons of copper concentrates, which has become 82,800 dry metric tons of copper metal. Total copper metal produced to date amounts to 126,300 dry metric tons. The major portion of the Bagacay mines is mined by the open pit method. Ore is primarily removed by drilling and blasting. The overburden or top layer of soil is hauled away and deposited in an area reserved for use in the company's reforestation program. The remaining materials are the copper ores, which vary in sizes and in grade. Copper ores containing 5% copper are shipped directly abroad, while those containing less than 5% copper are processed at the mill. Bagacay's mill concentrator, located some 2,600 feet from the pit, consists of a washing-crushing plant. Here, the ore is initially cleaned and broken down into smaller sizes. The crushed copper ores are then transported automatically to the milling plant for processing. Using the standard copper flotation process, the mill extracts the concentrate through a physical process whereby copper minerals are induced to adhere on air bubbles, especially created in the flotation tank. The bubbles with the copper minerals are skimmed off while the waste materials sink to the bottom and are passed on to another circuit, the pyrite flotation circuit. Recent geological findings have shown that Bagacay may yet be the source of another important mineral, a mineral crucial to the Philippines in the face of worldwide energy crisis. This mineral is coal, a traditional source of power. Today, Bagacay Mine averages 289,000 dry metric tons of copper ore, annually producing 26,000 dry metric tons of copper concentrates, subsequently producing 4,500 dry metric tons of copper metal a year. Copper concentrates and pyrite concentrates are transported from the mill at Bagakay via the longest tram line in the country. It extends 22 kilometers from Bagakay to Canaybon, the nearest deep-water pier in the area. With this cable line, the minerals are transported at the rate of 65 tons per hour. The trip itself takes 45 minutes, half of the time it would take to transport the minerals by land. To assure a smooth trip of these precious minerals, the speed of the bucket is regulated. In between Bagakay and Canaybon, an intermediate station serves as checkpoint. Safety inspectors also often take the trip itself to check the cables along the pathway. At the end of the 22-kilometer trip, the minerals are transferred by conveyors to ocean-going vessels, which bring the minerals to the international market. Because of the Bagakay copper mine's operations, this part of Samar has achieved a measure of economic prosperity. It has provided Samar with a steady and reliable source of income for hundreds of its residents. In the hilly terrain in Sipalay Negros Occidental in the Visayas, 170 kilometers south of Bacolod City, lies Marinduque Mining's principal copper mining property. The mineral deposits were first discovered in 1936, and commercial production started in 1957. Today, the copper mines consist of 33 leased claims covering 297 hectares. Outside of the mining area, the company maintains a thriving community on 1,500 hectares of land. Here, more than 1,700 Sipalay workers live in company-built houses. Every day, early in the morning, company buses transport the workers to the mining site. The trip takes only 20 minutes on roads also built by the company. At the mine site, everything is set for another mining day. The Sipalay mines have been profitable to the town, for it has given the townspeople a steady source of income since it went into operation in 1957. It has taught workers in the area new skills with which to earn a decent living. Like Bagakay, the Sipalay mines utilize open-pit mining. To get to the ore body, powerful electric shovels excavate a thick layer of overburden and waste rocks. What is most critical in open-pit mining is the manner in which primary blasting is carried out. The procedure is a science by itself. It begins with careful study and mapping of the area. For while it is essential to get to where the ore body is located, the miners must also keep the benches 12 meters high and the slope at 30 degrees angle. After pinpointing the areas which must be blasted, giant rotary drills bore holes, approximately 50 of them, at various strategic places. The drills penetrate 12 meters underground. Samplings are made at this point and sent to the laboratory for analysis. Numerous chemical tests are undertaken to determine the quality of the ore. Meanwhile, at the mine site, engineers lay down the lines for blasting. 1,000 pounds of ammonium nitrate are poured into plastic bags which are slid into the holes. The broken ore is loaded into huge 75-ton trucks, which hold the ore to the primary crusher at the edge of the mining area. From the primary crusher, where big boulders are broken down to size, the ore is conveyed to the crushing plant for further crushing and washing. Once the broken ore enters the crushing plant, it undergoes a series of crushing and washing until it attains the ideal size preparatory to the grinding process. The crushed ore is then fed to the grinding mills, where the ore is conditioned by reagents and then fed to the upgrading circuit. The process from here on is similar to that of Bagakay. It starts in vats called flotation cells. Water and chemicals are added to the crushed minerals in the vats and stirred vigorously. Sulfide particles adhere to the bubbles, while other particles sink to the bottom of the cell. As the mineral-bearing froth rises to the surface of the flotation cell, it is scraped off by paddles into a trough called a launder. The launder delivers the sulfide concentrate to a dewatering area. The process here involves the thickening of the concentrate as it passes through a series of canvas-covered filters which rotate slowly. As the layer of copper concentrate falls off, they pass on to a conveyor for transport to the storage cabin. A significant part of the Sipalay mill flotation process is the regrinding of the copper concentrate into other stages of flotation cleaners to obtain molybdenum concentrate. Molybdenum is a byproduct of copper, which is essential to the steel industry. Both molybdenum and copper concentrates are transported from the mill by trucks to the pier facilities in Calatan, on the southwest coast of Negros Island, 8 kilometers from Sipalay. Because there is no deep water pier in this part of the island, the concentrates are transported by barges to Japan-bound ocean-going vessels anchored farther out at sea. "23 kilometers from Manila, at the foothills of Rizal and near the time-honored shrine in Antipolo, lies Marinduque Mining cement operations. Its two electrostatic precipitators installed at the cost of $375,000 each tower above all else in the area. Island Cement is the largest cement plant in the country, producing 60,000 bags of high-quality cement daily. The manufacture of cement starts at the quarry, which has reserves estimated to last for 100 more years. Limestone, the principal raw material, is blasted from the quarry and hauled to the plant for processing. Limestone is fed to the primary crushers, where it is crushed to about 25 centimeters in diameter. From there, it goes to the secondary crushers, where it is further reduced to 3 centimeters. The crushed raw materials are brought to their respective compartments in the bulk storage material area by means of conveyors. As grinding goes on, water is added to the crushed materials to produce a brownish, thick substance called the slurry. The slurry is then pumped into the blending silos for further homogenization. The slurry is then passed through the kiln, where the mixture is burned and where carbon dioxide and other compounds are formed. The granular substance that comes out of the other end is called clinker, which is air-cooled as it passes through a mesh sieve. After cooling, gypsum is added to the clinker and then fed to the finished grinding mill. The mixture obtained is then pulverized and refined. What comes out at the end of this final process is cement. From the silos, where cement is initially stored, cement goes to 4-tube packers, where it is automatically packed in 40-kilo bags. In the case of bulk cement, the product is directly withdrawn from the silos to the bulk carriers. Island Cement has its own paper bag plant which supplies its packaging requirements. With the country's booming construction industry, Island Cement finds a ready market through its hundreds of dealers all over the Philippines. Some 450 miles southeast of Manila, in Nonok Island off Surigao Province in Mindanao, lies one of the world's richest deposits of nickel. It was once an expanse of idle land, sparsely populated, subsisting mostly on the yields of the land and the bounties of the sea. In 1975, Marinduque Mining and Industrial Corporation transformed the island into an industrial center with heavy machineries and gigantic engines turning out precious minerals of nickel and cobalt. The nickel refinery straddles 6 hectares of land and took 4 years to build. However, it represents the culmination of a dream that spanned 60 years of careful planning and actual demonstrations. The rich laterite nickel deposits in Surigao were first discovered in 1933. However, processes to extract nickel at that time were not suitable to this type of nickel deposits. The process was finally evolved during World War II. One of the companies which developed this process was Sherritt Gordon Mines Limited of Canada. Cabarrus, realizing the potentiality of the nickel deposits, entered into an agreement with Sherritt Gordon to utilize the process. At the same time, he made a bid to the Philippine government for the right to mine the area. In 1968, Marinduque's bid was chosen among all others. At the initial stage of the project, the process was tried out on a pilot scale in a demonstration plant in Canada. After it was proven workable, MMIC began construction of the nickel refinery in 1972. In 1975, the refinery, which cost $250 million, was completed. The completion of the nickel refinery was a milestone in the country's economy. for it represents another pioneering effort in the country's program to develop its rich natural resources. Nickel comes from the loose, rich red soil in the nearby mine site. Called laterite, the ore is scooped from the earth with the use of huge and heavy drag lines and transported to the crusher for crushing. The crushed ore is then conveyed to 90,000 metric ton stockpile where the ore awaits processing. The nickel ore at the Surigao Nickel Refinery is processed with the use of a tested procedure supplied by Sherritt Gordon of Canada. The processing of nickel begins at the multiple hearth roasters where the nickel is reduced by hydrogen into nickel sulfides. The roasted ore is then cooled and leached with the use of ammonium carbonate solution. The leached ore is then thickened into two gigantic sealed leach thickeners. After passing through the thickeners, cobalt is removed from the leach products by the reaction with hydrogen sulfide. Nickel powder is then briquetted, sintered, and packed for export. At every stage of the process, quality control measures are undertaken. The refinery has an assay laboratory precisely for this purpose and a certification machine that safeguards the quality of the nickel. This certification machine is one of the 5 such machines found in the country. Precision is so important to the refinery that the entire operation is controlled by advanced computers. In support of the nickel processing operation, the Surigao Nickel Refinery has several gas plants to produce the gas necessary for the various procedures. These are the hydrogen and the nitrogen plants. The refinery also has a power plant to generate steam and power to run the plant. This includes huge boilers, turbine generators, and a 5,000 kilowatt standby diesel power plant. The refinery itself is impressive. Large stationary boilers, the world's largest hot roasters and thickeners, big enough to house a football field, have unmistakably changed the skyline of the area. But more than this, the nickel refinery has changed the life of the town. It has transformed the small island into a community of 15,000 people thriving on the benefits of industrialization. A major dam in nearby Dinagat Island, which took 3 years to construct, pumps 10,500 gallons per minute of fresh water into Nonok Island. The island boasts of an airport with a 3,500-foot runway and a water port facility that can berth 80,000-ton ocean-going vessels. The company has built staff housing for the more than 2,000 workers who operate the refinery. What Marinduque Mining has done for Nonok Island is typical of the contributions the company has given to the communities in which it operates. Marinduque Mining and Industrial Corporation has provided for its people excellent opportunities to enjoy the good life. Sports are encouraged in its numerous company-maintained pelota courts, tennis, and basketball courts. Marinduque Mining has also taken care of the education needs of the children of the workers. In Sipalay, the Cabarrus College offers complete education from grade school through high school to college. Students are taught not only the basic skills, but also vocational skills. The company provides for complete health care for the workers and their families. And, as in the rest of the country, festivities are held at the mine sites. Festivities that remind one and all of the joys of being alive, of having one's own culture. Today, more than 6,000 people depend on Marinduque Mining and Industrial Corporation for their livelihood. More than this, the country depends on it for more than $190 million in foreign exchange earnings. But the greatest significance of Marinduque is its contribution to the Filipino people and the efforts towards self-reliance. With men like Jesus Cabarrus, and with successes gained by MMIC's operations, mining has proven to be a great storehouse of wealth in the Philippines. Today, the eyes of the mining world is focused on the Philippines. Mineral rich, this nation has barely scratched the surface of its potentials. But it takes men of daring spirit, imagination, know-how, like the men of Marinduque Mining and Industrial Corporation, to plumb the depths, face the challenge of the unknown, and conquer the forces that determine success.